You have very likely heard of cinnamon. True cinnamon comes from cinnamon bark, which contains mostly cinnamaldehyde, but also contains other flavor components including benzaldehyde and para-isopropyl benzaldehyde. Cinnamaldehyde is used to flavor candies, gum, and baked goods. Synthetic cinnamaldehyde, which is mainly the trans isomer, is made using an aldol condensation, which we will study further in Chapter 22. The Wittig reaction is used to make an alkene using a carbonyl aldehyde or ketone, along with the phosphorus ylide. The ylide acts as the nucleophile to the carbonyl electrophile. Triphenylphosphine oxide is eliminated in the process. You will carry out the ylide-forming reaction in the presence of cinnamaldehyde, which reacts with the ylide to form the product. The reaction occurs at room temperature in a biphasic mixture, where sodium hydroxide is present with dichloromethane, forming two layers in the reaction mixture. The necessary reaction intermediates will transfer back and forth between aqueous and organic layers as needed. Most of the product will remain in the organic phase and will later be extracted from the aqueous phase. The product will need to be purified using trituration, which takes advantage of solubility differences of the compound versus its impurities in a solvent or solvent mixture. You will dissolve your impure product in a minimum amount of solvent in which it has moderate, strong solubility. While stirring, you add a solvent that will not dissolve the product in order to precipitate the product out. Once most solid crashes out, the solid can be filtered. The product can then be recrystallized with ethanol. You will need to determine the stereochemistry of your product using its melting point. Add trans-cinnamaldehyde to a 3 ml conical vial. Add dichloromethane, benzyl triphenylphosphonium chloride, and a stir bar. Add sodium hydroxide while stirring. Attach an air condenser and clamp the apparatus. Stir vigorously at room temperature for 30 minutes. Transfer the mixture to a separatory funnel using dichloromethane followed by water to transfer. Shake the separatory funnel gently but thoroughly for extraction. Collect the dichloromethane layer and dry it with sodium sulfate. Collect it in a clean, dry 5 ml conical vial. Evaporate the dichloromethane using a slow airstream and gentle heating on the hot plate until an oily or solid residue remains. Add ethanol to the residue and triturate the solid with a microspatula. This can be done by pressing the solid against the sides for several minutes to remove impurities. Collect the solid by vacuum filtration, washed with ice-cold ethanol. Recrystallize with ethanol. Filter the product, measure the mass, obtain a melting point. Determine if your product is EE or EC.